Good morning. If you have not already watched it, please watch this video first. The All I Do Is Solve. It's a great music video. And it has what we need. So we're going to start with the graphing method first. It's honestly the easiest method, and students very much enjoy this method. So today's going to be some quick notes. Our warm-up, you can pause and try these first and come back to check, because you should be able to do 1 and 2 on your own. All right, now that you've tried them on your own, if we see this is in y equals mx plus b format, right? Back to the equal signs. So we know it's just a solid line, no coloring. So we go from our y-intercept and we go down 1, 2, 3, and we put a dot. All right, there's our y-intercept. Our slope is 1/2, so we go up 1 over 2, put a dot, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Oops, that was not over 2. All right, we can continue in the other direction, and then what we got to do is connect our points in a linear line. Don't forget the arrows because it says it keeps going forever and ever in both directions. Now, any ordered pair on this line is a part of the solution for this equation, right? So if we take this lattice point, 1, 2, 3, 4, -1, if we substitute those values in, we'd have a true equation. That's important for today. All right, for this one, I'm going to use intercepts to review that one. So if we go for our x-intercept here, let me just use, okay, there we go. If I go for my x-intercept, I want a value for x when y is 0. So if I plug in 0 for y, I'm going to solve. So I'm just going to have 8x is equal to 16. So my x-intercept is 2. On x, I have a dot at 2. Again, you could solve to get it into y equals mx plus b, but to review this intercept method, all right, and then my y-intercept, I want a value for y, so I'm going to plug in 0 for x. So I plug in 0 for x, 0 times 8 is 0. We are just left with 4y is equal to 16. When we divide, we get y is equal to 4. Cool. So we go up to 1, 2, there we go. All right, from there we can see our slope is a -2. So we can then continue filling in our dots there from what we have. And we can do it in both directions to make a beautiful straight line. Make it beautiful. Lovely. Arrows at the end. All right, cool. So basically what we're going to do today is do that same thing, but graph both of them on the same graph and see where they cross. So according to the song, they start to sing, so graph your first line. Now graph the other one too. The intersection is your answer. That's all you've got to do. So if we graphed these two, which they did, so here's our set notation. We graphed our first equation. So with -2, which is the red line here, and they went up 2 over 1, up 2 over 1. And then this one, our y-intercept was at +4, and they went down 1 over 1, down 1 over 1. So the first one's the red one, the second one's the blue one. All you've got to do is see where they cross. So that is our answer. Why is it our answer? Well, this point over here is true for only the red line. This point over here is only true for the blue line. We want a solution that's true for both. So since they both cross at this point, is that 2, 2? Yes, it is 2, 2. So since they both cross at 2, 2, that ordered pair is our solution to the system of equations. It's true for both of those. Ta-da! All right, this one. Sometimes the lines are the same. That's infinite solutions. So if it's the same line, and you can kind of see it on my screen, it's tougher to see on your paper, but the red one is graphed here, and so is the blue one. They're graphed right on top of each other. So every single ordered pair, including all those fractions and decimals within there, are all true. So whatever we put for this, we can put in for this, and it's true. So we have infinitely many solutions. Or infinite solutions, because That's all the space we have. Did I spell that right? Ooh. Yes, beautiful. And finally, we have lines that we haven't talked about in a while. Sometimes they never touch. No comma and points producing. So if we keep those lines going forever and ever, they will never, ever cross. They're called parallel lines. How do we know they're parallel lines? Remember, parallel lines have the same slope. So it's been a while since we've reviewed that. So they have the same exact slope, and notice their y-intercepts are different. Over here is the exact same y-intercept. Here they're different. So the same slopes, they will be parallel, and then we have no solution. Most of the time, we're going to get an ordered pair. Occasionally, we get infinite or no solutions, occasionally. All right, so you're going to solve these. Notice, look, the self-check answers are right here and right here. So I want you to then graph both of these, practice your graphing, and look, you can check your answers when you're done. So these two should cross at -3, -1. If not, bring your questions to class. These ones will not cross, so you'll see some parallel lines here. Awesome. All right, so then you're going to write this. Oh, here, let me write a little text box here. I'm going to have you, and I'm going to write it out because I know people don't always listen to my voice. Answer this question. This one. This one. We're going to discuss it for our warm-up when we get into class. All right, well, we'll save the elimination method and substitution method for the future. That's it. That's all.